So this example will illustrate the steps to get distance traveled, and this question happened to give there are two change in direction. So this one starts from the displacement. If you look at the formula, so the formula starts from displacement. Okay, so there's only I'm only getting the total distance traveled, so I will just try to differentiate to get the velocity parts. Okay, you could carry on to differentiate to get acceleration, but in this question, we don't need the acceleration. We are just trying to get the distance traveled. So if you look at the steps will be find out the change in direction first. So that's what I will do. So I'll find out the change in direction by setting the velocity to 0. So if I set velocity to 0, I get a quadratic expression. So in this case, I will have two positions. Okay, let's see whether the two positions are valid. So you will get t equal to 1 and you will get t equal to 5. So these are the two timing that the particle decides to reverse the direction. So we don't know the position yet. So later on, we need to know the position. So if you observe the two timing is within the first 8 seconds. So the first timing, these two U-turn timing is within the first 8 seconds. So which means, right, it will affect how the distance is being traveled. So again, I'm going to find out the starting position. The starting position is t equal to 0. And I got to find the U-turn position. So, but currently I got 2 U-turn. So this will be the 2 U-turn position. Okay, then I got to find the end position. The end position will be at t equal to 8. So you trace the position first. The displacement formula is like a GPS tracker. It traces the location. So I'll get a location 40. I get a location 47. Okay, punch your calculator carefully. So I get a location 15. Okay, just make sure you punch carefully. So these are the location. They move in order of timing. T equal to 0, we start with position 40, and we move to position 47, and we start to reverse. Okay, so this is the second step. The third step is the drawing. We try to trace the path. So if you see the displacement formula as a GPS tracker, you actually trace the path. So make sure your line is sufficient to contain all the numbers. So it will just be you don't have to label everything. Just make sure all the numbers are there. So you start the tracing, you start from position 40. Then you move to 47. You move this direction and then you reverse to 15. And when you reverse to 15, you decide to reverse all the way till 96. So can you see? Can you see, like, you make a small little distance and then you reverse. So if you trace a path, then you calculate bit by bit. Okay, it's up to you how you would like to calculate. So maybe you calculate the longest first, The longest is the stretch from 96 to 15. And then you calculate the middle length, the length from 15 to 47. And this apparently is the shortest. So calculate layer by layer. So that's how you will get 120. So sometimes the number may not be so nice, particularly if you have trigo expression. The distance can be a lot of decimals, so you need to preserve the accuracy. We try not to use 3SF if the position is not a nice position, because if you use a lot of 3SF, your final distance will be compromised in terms of accuracy. So this will be the general 3 steps that you follow whenever they ask you for distance travel, which most people will get it wrong.